Hello viewers, welcome to Maths and Science Professor channel. We are looking at computer numbering systems and we want to look at binary and decimal numbers. We will start by converting binary to decimal numbers. Binary numbers are numbers in terms of 1 and zeros that can be understood by a computer, apart from the numbers that we know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the decimal numbering system. Now, for example, you can be told to convert a binary number to a decimal. Binary number, for example, 1, 1, 0. You can be told to convert 1, 1, 0, which is a binary number, to a decimal. The binary number is of base 2. Now, if you have 1, 1, 0, 2, and you have been told to convert it into a decimal number, you consider we have base 2. We will have 1 times 2 raised to power here we have 0, 1, 2 raised to power 2. We add 1 times 2 raised to power 1, and then we have 1 times 2 raised to power 0. So you see the powers are descending from 0 to 1. The powers are ascending from 0 to 1 to 2, and if we had a longer or a larger binary number, the powers would have continued to ascend in that manner. If we have 1 times 2 raised to power 2, that is 4, plus 1 times 2 raised to power 1, which is 2, plus 1 times 2 raised to power 0, that is 1. When we add all this, we have 1 times 2 raised to power 1 is 1 times 2 raised to power 2 is 4, and then we have 1 times 2 raised to power 1. Here we have 0. This is not 1. We have 0 times 2 raised to power 0. 2 raised to power 0 is 1 times 0 is 0, and then we sum up all this. We have our decimal system 6 to base of 10. Let's look at the second example. If you have a binary number 1, 0, 1, 1 to base 2, and then you want to convert it to a decimal number base 10. You have 1, 0, 1, 1 base 2. You have 1 times 2. Here is 0, 1, 2, 3. The powers are in ascending order, so we will have power 3 plus 0 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. If you add this, 1 times 2 raised to power 3, you have 8, plus 0 times 2 raised to power 2, you have 4 times 0 is 0, plus 1 times 2 raised to power 1, we have here 2 raised to power 1. Yeah, 1 times 2 raised to power 1, you will have 2. You will have 2, and then plus 1 times 2 raised to power 0. 2 raised to power 0 is 1. 1 times 1 is 1 plus 1 raised to power 0. So when you add all this, when you add 8 plus 0 plus 2 plus 1 is 11. 11 to base 10 is the decimal number for the binary number 1, 0, 1, 1, and 2. Let's say you have another binary number 1, 1, 1, 0. You have been told to convert this to a decimal number. You follow the same pattern that we have always followed, and then the powers are in ascending order, beginning from 0, power 0, 1, power 1, 2, 3. Now you'll have 1 times 2, 2 raised to power 3, plus 1 times 2 raised to power 2 plus I will have 1 times 2 raised to power 1 plus 0 times 2 raised to power 0. 2 raised to power 3 is 8 times 1 is 8 plus 2 raised to power 2 is 4 times 1 is 4 plus 2 raised to power 1 is 1 times 1 is 1 plus 0 times 2 raised to power 0 is 0. You add all these and you have 8 plus here we have 1 times 2 raised to power 3, 1 times 2 raised to power 2, and 1 times 2 raised to power 1 is 2. When you add all these, 8 plus 4 plus 2, you have a 14. 14 to the base of 10 as your decimal version of 11102. Let's look at the last example. Our last example, let's say you have a binary number 101 to base 2. You have been told to convert this to a decimal number. You say the power are ascending from 0 to from right to left. The power ascends from 0. You have 0, 1, 2, 3. So you will have 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. 1 times 2 raised to power 3, you have 8 plus 0 times 2 raised to power 2, we have 0. 0 times 2 raised to power 1 is 0 plus 1 times 2 raised to power 0, that is 1. This is 9 to the base of 10. Let's now convert decimal number to a binary number. For example, if we have 57 and then you want to convert it to a binary number, what you do is you divide by 2 all along, and then you have your remainder. You have 57. You divide by 2. If you divide 57 by 2, you will have 28. You will have 28. The remainder is 1. If you divide 28 by 2, you will have 14, and the remainder is 0. If you have 14 divided by 2, you have 7, and the remainder is 0. You have 7 divided by 2, you will have 3, and the remainder is 1. 3 divided by 2, you will have here 1, and the remainder is 1. You divide 1 by 2, 0, and the remainder is 1. Now this is the least significant bit. This is the least significant bit, and then here we have the most significant bit. When writing the binary form, you start from the most significant bit to the least significant bit. We'll have 1 1 1 0 0 1 to the base of 2. 1 1 1 0 0 1. And then let's say you have a second example. You have 15, and then you want to write it to a binary number. You do the same. You have 15. 15 divided by 2 is 7. You remain with 1. 7 divided by 2 is 3. You remain with 1. 3 divided by 2, you have 1, and you remain with 1. Divide by 2, you have 0, and then you remain with 1. This is the least significant bit, and this is the most significant. This is the most significant bit. You start from the most to the least. You will have 1 1 1 1 to the base of 2. Let's try out our third example. If you have a decimal number,
you have a decimal number 19, and then you want to change it to binary, you will do the same procedure. You have 19 divided by 2, you will have 9, and the remainder is 1. 9 divided by 2, you will have 4, and the remainder is 1. 4 divided by 2, you will have 2, and the remainder is 0. 2 divided by 2, you will have 1, the remainder is 0. 1 divided by 2, you have 0, and remainder is 1. Here we have the least significant bit, and here we have the most significant bit. You start from the most to the least. You will have your arrangement in 1, 0, 0, 1, 1 to the base of 2. Now this is how you can change a decimal number to a binary number. We have also looked at how you can change a binary to a decimal number.